Ladies and gentlemen, we are meeting today with a new video of the Engineering in Amharic YouTube channel series.
Technical drawing. What is perspective drawing in technical drawing? Perspective drawing is a way to represent 3D objects on a flat surface. Using perspective drawing conveys depth, space, and extension of an object, tool, part, or building. Autodesk Inventor software makes it easy to apply perspective to a custom drawing view. Why is technical drawing important in the manufacturing industry? Detailed technical drawings communicate the design intent of the item to be manufactured and assembled. They help the manufacturer understand how to build or construct something to a specific size, form, and function to enable it to work correctly. Technical drawing details help streamline the manufacturing process in two ways. They reduce the time spent from design cycle to production and eliminate errors and waste associated with missing or incomplete manufacturing information. How do you read technical drawings? To read technical drawings, refer to the many information blocks provided on the drawing. The title block, located on the bottom right corner of the drawing, includes a description of the drawing, information about the materials to be used, scale, tolerances, size, part numbers, and more. The revision block, located in the upper right corner, explains revision details or changes made to the original drawing. The bill of materials block, above the title block or on the upper left corner, includes a list of all the items or quantities of materials needed to assemble the object or structure. The drawing key explains various symbols and lines that can identify the different features of an object or structure. The scale number will explain the scale the drawing should be produced to. For example, 1:1 means the drawing represents the actual size of the object and 100:1 means the actual object is 100 times the size of the drawing. What is pattern development in technical drawing? Pattern development in technical drawing is the creation of a flat representation of a three-dimensional object. True pattern development uses parallel lines, radial lines, or triangulation so that every surface on the pattern is the same size and shape as the corresponding surface of the 3D object. Why is technical drawing important to architecture? Technical drawing is an important component of architecture because it provides insight into what the final structure will look like in its relationship to its surroundings. Architecture technical drawings illustrate a finished structure, show exact dimensions for construction, present how different parts of the structure fit together, diagram the arrangement of species within the structure, and reveal mechanical and material details necessary in constructing the project. Autodesk's architecture software empowers efficient and seamless technical drawing for architects. First versus third angle, orthographic views. Orthographic views allow us to represent a 3D object in 2D on a drawing. Orthographic views can show us an object viewed from each direction. How the views are laid out on a drawing depends on whether third angle or first angle projection is being used. You can tell which angle projection is used by the symbol shown on the drawing. First angle projection. First angle views are less intuitive. The front view is shown in the center, just like in the third angle projection. To place the view of the right side, you must tip the box so that the right side is facing you. To do this, the box must be tipped toward the left. This results in the right side view of the object being located on the left side of the front view. With the front side facing you once more, tip the box to the right, and you will have the left side facing you. So, the left side view will be located to the right of the front view. This same method is used for top and bottom views. With the front of the object facing you, tip the cube downward. You now have the top side facing you, with the top view being located under the front view on the drawing. By tipping the front view upward, the bottom view of the object is facing you, with the bottom view located above the front view. Again, there is common confusion about the symbol representation for first angle project. There are 4 ways first angle projection can be represented on a print. The big takeaway here is it does not matter if the side view of the cone is on the right or left. For first angle, the pointy end of the side view of the cone in the symbol is always pointing away from the front circle. All 4 of these are perfectly acceptable for first angle. Third angle projection. Third angle projection can be visualized by unfolding the box, as if the object itself is being unfolded to show the views from each side. Third angle views are intuitive, as they represent you looking at the object from the corresponding side. The front view is always shown in the center. The view of the object from the right is shown to the right of the front view. The view of the object from the left is shown to the left of the front view, and the top and bottom views are shown above and below the front view, respectively. If we needed to show the view from the back view would be placed below the bottom view. Quick note on representation of the symbol for third angle. There are actually 4 ways third angle projection can be represented on a print, and all of them are acceptable. The big takeaway here is it does not matter if the side view of the cone is on the right or left. For third angle projection, the pointy end of the side view of the cone in the symbol is always pointing towards the front circle. All 4 of these are perfectly acceptable for third angle. Third angle versus first angle orthographic views. As you can see from figures 1 and 2, first and third angle orthographic views are opposite in where the placement of each side's projection view is located on a drawing. If a person is not aware of which angle projection is being used on the drawing, it can cause a lot of confusion. It is important to remember to look for the projection symbol and understand whether the symbol refers to third or first projection views. To help you remember which symbol belongs to which view, let's look at the symbol for each. Each symbol represents the views of a cone from that angle view. Both third and first angle symbols show the circular top view of a cone and the right view of the cone. The difference in symbols is where the right view of the cone is located. The third angle symbol is represented by the circular top view of the cone with the right view of the cone to the right of it. In the right side view, the narrow end of the cone is pointed towards the top view. The first angle symbol has the circular top view of the cone with the right view of the cone to the left of it. The narrow end of the cone is pointed away from the top view. By paying attention to the direction the cone is facing, you see that it can't be a left view of a third angle projection because the narrow end of the cone would be pointing towards the circular top view. By looking at the shape of the cone, you see that it must be the right view of the cone. Because the right view is located on the left side, you are looking at first angle projection. As you can see, third and first angle projections show the same information on a drawing but oppositely locate an object's views. Paying close attention to the view symbol will prevent much confusion when reading a drawing.
Thank you for watching.